Welcome to Build for the Build. I build things because it's fun and let me explore areas outside my comfort zone. I challenged my kid to do some cat drawings. We talked about what to draw. He came around to the idea, let's make a water cannon. Spot on, let's make a water cannon. A base with a pan stepper motor mounted and a spray protection shield on top. A U-shape to hold tilt stepper motor, an upside down U-shape mounted on the stepper to hold and tilt the water nozzle. And here is the final assembly with the base, the shield, the U-shape and the reverse U-shape with the pan stepper motor and coming around to the tilt stepper motor, and then on top the water nozzle. My first idea was to drive the water by air pressure from a compressor that have an air valve that pushes air into the bottle and then a hose that the water can escape through and go to the gun. The first prototype with air supply, the valve, and the 1 liter water bottle, and the gun nozzle. Controlled by a PC that had a USB driven I/O board, and from the I/O board 4 outputs to drive the stepper drivers that again drive the stepper motors. Here you have a close-up of the model with the PC, and we are zooming into the GPIO board and the stepper drivers, just to show how fast the bottle will empty with air pressure from the compressor. Here's a short demo. Emptying half a liter of water that fast and then have to refill it is not feasible for me. My second attempt to make an unlimited water supply for the water gun was using a salvage valve from an old dishwasher. Only issue is this is using 230 volt AC, so I needed to attach a relay board instead of the air valve. Firing the gun went fine, the water started flowing, but when releasing, the current buildup in the valve coil will kick back into the relay board and then will kick back into the GPIO board. This will render the GPIO board useless and lose communication with the PC. Back to my previous explainer. Here you can see the solution was adding a capacitor between the live and the neutral wire. The capacitor will kill any kickback and ensure the boards are not damaged. Using a keyboard to control the water gun is an obvious solution, but being close to the water gun, hence being close to the PC, will probably draw you into a water fight. And everybody knows that water, computer, electricity doesn't match very well. To me, the obvious choice was to use MQTT, one program, the remote, listening for actions and posting them on a topic. And you have the water gun listening to the topic and executing the actions. From my heap of USB devices, I pulled this joypad controller. I made a small program that reads the buttons from the joypad, the up, down, left, right and fire, and sent the appropriate command, including an idle when you let go of the button, over the MQTT topic to the water gun.